Now we'll be looking at linear inequalities in one variable. And what does this mean? This is one which involves a linear function with one variable. As you will know, a variable represents a number that is not fully specified. So in this case, by having one variable, we have means we have only have one unknown, which is like x in these two equations as shown here. So how do we solve for the value of x when we have inequality symbols in between expressions? So the same way we proceed is the same way we would normally proceed if we have the equals to sign instead of the inequality sign, but there are just a few tweaks to it. So let's start by trying to solve this. So first, we have 2x plus 3 greater than 5. So as we do, we subtract 3 from both sides first. So we have what? 2x plus 3 minus 3 be greater than 5 minus 3. So I have what? 2x being greater than 2. Then I divide both sides by 2. And what do I have? I have what? X greater than 2 divided by 2 is 1. So this results in what? X greater than 1. As you can see, the same procedure is being followed, only that I have a greater than sign here. So what does this mean? It means that for all value for which x is greater than 1, this inequality symbol is satisfied. So let's take an arbitrary example now. So an example of a number greater than 1 is what? 2. So let's say x is equals to 2 and try to substitute it here. When we do that, what do we get? We get 2 into bracket 2 plus 3 is greater than 7. And what does that give us? 4 plus 3 is greater than 5. So this is a 5 here. So what do we have? We have 7 is greater than 5. We can see that 7 indeed is greater than 5. But now let's look at a number that is less than 1. And a number that is less than 1 is 0. So let's assume, for instance, that x is equals to 0. So I will substitute it in the inequality here. So we have what? 2 into bracket 0 plus 3 is greater than 5. And we're left with 3 is greater than 5. And we can see that this is nonsensical because 3 is not greater than 5. So what this inequality means is that for all values for which x is greater than 1, this inequality will be satisfied. So let's try to solve this second example over here. So here we have 7x minus 3 greater than 11. So I can add 3 to both sides, or I can bring the minus 3 here. Anyway I want to go through it. So this should give me what? 7x is less than 11 plus 3. So I have what? 7x is less than 14. And if I divide both sides by 7, what do I have? I have x is less than 2. So what does this mean? It means for all value for which x is less than 2, that is x is not up to 2, then this inequality expression is satisfied. Now let's consider the concept of less than or equals to and greater than or equals to. So we have less than or equals to, like we have discussed before, less than and greater than, and these are called strict inequalities. But sometimes we can have weak inequalities, and this is when you add equal to sign to the inequality sign. So here what this means is less than or equals to. For example, we have 7x minus 3 is less than or equals to 11. So what does this mean? Try to solve it normally like we do. So this gives us what? 7x is less than or equals to 11 plus 3, and that is 7x is less than or equals to 14. And if I divide both sides by 7, I have what? X is less than or equals to 2. So what does this mean? What this means is that for all value for which x is less than or equals to 2, this inequality is satisfied. So first, to try that out, let's try to make x to be equals to 2. So if x is 2 and I substitute it here, what do I get? I have 7 into bracket 2 minus 3 is less than or equals to 11. I have 14 minus 3 is less than or equals to 11, and 14 minus 3 is 11. And I can see that 11 is indeed equals to 3, and the inequality say the value here must be less than or equals to, and we can see that it's equals to. So now let's consider another scenario in which x is less than 2. So for example, let's assume that x is equals to 1. And when we do that, we substitute the value of 1 for x. We have 7 into bracket 1 minus 3 is less than or equals to 11. And what do we get? We get 7 minus 3 is less than or equals to 11, which is us as 4 is less than or equals to 11. And as you can see, 4 indeed is less than 11. Now finally, let's consider a scenario in which x is greater than 2. So let's assume that x now is say 3 and we substitute it here. What do we get? We get 7 into bracket 3 minus 3 is less than or equals to 11. So what do I get? 7 times 3 is 21 minus 3 is less than or equals to 11. And what do I get? 21 minus 3 is what? Is 18. I get 18 is less than or equals to 11. And as you can see, this is nonsensical because 18 is not less than and is not equals to 11. It is greater than. So what this means in summary is that for all values for which x is less than or equals to 2, this inequality symbol is satisfied. So same applies to this second example. So here we just proceed. We have what? 2x plus 3 which is greater than or equals to 5. If I bring this 3 over here, I have what? 2x is greater or equals to 5 minus 3, and I have 2x is greater than or equals to 2. And if I divide both sides by 2, I result in what? X being greater than or equals to 1. So this is the solution to this inequality. Now we're going to be examining something that is special. So before I start, I would like you to note at the back of your mind that if I write x greater than 3, it is the same as writing 3 is less than x. For example, if I write 7 is greater than 3, is equivalent to writing 3 is less than 7. They are both equivalent, but that is by the way. But this will come in really handy now. So now sometimes when solving an inequality, you'll be left with minus x on the left hand side. Then when you divide both sides by minus, you have to reverse the inequality sign for consistency. So as shown in the next example. So what do I mean by that? Let's try to solve this inequality, this question that has to do with inequality. So we start out. We take this 11 to the other side, so we have what? Minus 2x is less than what? 4 the minus 11. And what do I have? I have minus 2x is less than 4 minus 11 will give me minus 7. So now what do I have to do? I have to divide both sides by minus 2. So what the law is telling us that if you are dividing both sides of an inequality or multiplying both sides by a negative number, we have to reverse the inequality sign. So when we cancel here, we have what? X. So now we have to reverse this inequality sign because you have divided both sides by negative number. So this only applies if you are dividing both sides or you are multiplying both sides by a negative number. So you reverse the sign and this becomes x greater than, and 7 divided by 2 is what? 7 over 2 or 3.5. Let me write as 7 over 2. So now why are we reversing the sign? This example will give you an idea of what I mean. So now let's imagine that x, let's assume we didn't reverse the sign. So what would have resulted in? Would have gotten what? X to be what? Less than 7 over 2. Now let's try to fix to see if this law is applied of this. So now let's think of a number that is less than 7 over 2. A number that is less than 7 over 2 will be what? 2. 2 is not to 2.5. So let's assume that x is equals to 2. And let's try to substitute it here. So what do we have? We have 11 minus 2 into bracket 2 is less than 4. So I have what? 11 minus 4 is less than 4. And what do I have? 11 minus 4 is what? 7. I have 7 is less than 4. As you can see, this is nonsensical because in reality 7 is greater than 4. So this explains why when you are dividing by a negative number, you need to reverse the inequality sign. So as we have reversed it here, let's try to take a look at an example. So here now, let's assume that we reverse the sign. So what would be left with? We have the result as what is here, which is what? X greater than 7 over 2. So let's pick an arbitrary number that is greater than 7 over 2. So let's assume that x is equals to 4. And we substitute it here. So we have what? 11 minus 2 into bracket 4 is less than 4. So we have what? 11 minus 8 is less than 4. And what do we have? We have 3 is less than 4. As you can see, this is sensical because 3 is less than 4. So to recap, when you are dividing the sides of an inequality expression, both sides by a negative number, or multiplying both sides by a negative number, you have to what? reverse the inequality sign. So let's move on to this second example over here. So here we proceed normally, we expand. Minus 2 times 13 gives me what? Minus 26 plus minus 2 times x gives me what? Minus 2x. Then is greater than or equals to 9 plus 5x. So you collect like times, you bring this over here. So you have minus 2x. When you bring this over here, you have what? Minus 5x is greater than or equals to, you bring it over here, you have 9. And you bring it over here, you have what? Plus 26. Minus 2x minus 5x gives me minus 7x is greater than or equals to 9 plus 26 gives me 35. So now I have to divide both sides by minus 7. So as you can see, I'm dividing, sorry, this is 35 and not 36. I'm dividing both sides by a negative number. So when I divide both sides by a negative number, what do I do with the inequality sign? I reverse it. So this becomes what? X is what? Is less than or equals to minus 5. So this is the result. So now, how do we express inequalities in number line? We are going to be looking at that briefly. So what is a number line? A number line is a picture of a graduated straight line that serves as abstraction for real numbers. So what does it mean? A number line, you have a straight line from between 2 points. Then you have the center, which represents the origin. So here you have the origin, which is noted as 0. And all numbers that rise to the right are positive numbers. So you have what? 1, 2, 3, 4, 5. And all numbers that lie to the left are negative numbers. You have minus 1, minus 2, minus 3, minus 4, and minus 5. That's a number line. So how do you know which numbers is bigger when dealing with number line? So numbers that lie to the right are greater than numbers that lie to the left. So now, what does this mean? For example, let's take two examples now, 3 and let's say minus 2. So we want to determine the inequality sign between them. So first, we look at or identify where they are located. So 3 lies here and minus 2 lies here. So which one lies to the right? We can see minus 3 lies to the right and what? Minus 2 lies to the left of minus 3. So this means that what? Minus 3 is greater than minus 2. So 3 is greater than what? Minus 2. As a second example, let's imagine you have two numbers now, minus 4 and minus 1. So you look for them, you have minus 4 here and we have minus 1. So you can see that minus 1 lies to the right and minus 4 lies to the left. So minus 1 is greater than minus 4, or minus 4 is less than minus 1. So just note that numbers that lie to the right are greater than numbers that lie to the left of that number rather. So now how do we express inequalities in number line? So let's look at some quick examples to explain how this is done. So first and foremost, we want to explain x less than minus 5. So the first thing you have to do is to draw the number line, and we have just mentioned that is a straight line made up of a straight line that is graduated. So here you have what? 0. I know positive number lies to this side, so you have say 1, 2, blah blah blah, and in the negative you have what? Minus 1, you have minus 2, minus 3, minus 4, and minus 5. So now we are told that x is less than minus 5. So what does it mean? It means that all the values of x are not up to minus 5. And we have already said when the number is less than a number, it means it lies to the left of that number. So what we are going to do is that we are going to draw a straight line up just to trace it. Then we draw a circle, a small circle on top of it. Then now, since it tells us that x value is less than minus 5, then it lies to the left. We just draw an arrow that points towards the left, and we'll write our inequality on the line. So we have what? X is less than minus 5. So what this means is that first you draw the number line, then locate the number minus 5, and we're told that x is less than. So you just draw a circle on top and you take it backwards since you are going to the left. Now let's try another example in which you have x is greater than 3. So first and foremost, what do? You draw the number line, and when you draw the number line, locate 0, then you try to locate 3. So look, 3 will be on the positive axis, so 3 will be somewhere here. but now we are told that x is greater than 3. So first we draw the line up, then we will draw a small circle on top. But we are told that x is greater than 3. And what does greater than mean? It means that x lies at the front of 3. So we just draw an arrow towards this direction and we have what? X greater than 3. So now how do we deal with inequalities that have equal to sign? So here we are told that x is less than or equals to 7. So first and foremost we do the same thing, we draw the number line and we try to locate the number. So we have our 0 here and we know that our 7 will lie somewhere around here. We are told that the value of x is less than or equals to 7. So first we draw the straight line, we draw our circle and we are told that it's less than, so it will come towards this direction here because it's less than, and we write what? X less than or equals to 7. But now because we have less than or equals to sign, we have to paint that tiny circle that we have drawn on top. So we shade it. So that is how we differentiate. When we have a strict inequality in which we just have less than or greater than, we do not shade it, we just leave it as blank as a circle. But when we have less than or equals to, then we shade that tiny circle over there to distinguish between just having strict inequality. So let's try to solve for x greater than or equals to -4. So first and foremost, what do? We draw our number line, we locate our point of origin 0. We know that -4 will lie to the left, so we just label -4. And when we get there, we are told that x is greater than or equals to, so we'll come up. Greater than means the value of x lies to the right of -4. So we shade it now since we are having greater than or equals to, and we point our arrow towards the right direction to have the value of x being greater than or equals to -4. So that is how we express inequalities in number line. So let's look at an example. So here we are told to solve this inequality and express in the number line. So what is the question? We are told that 2/3 minus 3x is less than or equals to 2 into bracket 1 minus x. So first and foremost we have to expand. So we have 2 minus 3 minus 3x is less than or equals to 2 times 1 is 2, 2 times minus x is -2x. Then we collect like times. So we have minus 3x. When this comes here, it becomes plus 2x. Then we have is less than or equals to 2 minus 2/3. So what does this become? Minus 3x plus 2x gives me minus x is less than or equals to 2 minus 2/3 gives me gives me 1/3, which is same as 4/3. So now I can divide both sides by -1. So when I divide both sides by -1, I have my x, and since I have divided by a negative number both sides, I change my inequality sign to greater than or equals to and I'm left with -4/3. So how did I draw this on the number line? First and foremost, as I've explained, we first draw the number line like this, locate the point of origin 0, then locate the number -4/3. So if 1 lies here, for example, and 2 lies here, so -4/3 will lie somewhere here. So you have -4/3. Let me include the negative numbers here, and you have like 1, 2. So now we're told that the value of x is greater than or equals to -4/3. So from that -4/3 point, we draw a straight line up, and what do? We shade the circle because we have greater than or equals to, and we move it towards the right direction. So what do? We have our x value is greater than or equals to -4/3. So now we're talking about range of values. So this involves combining two inequalities into a range that satisfies both inequalities. So what do I mean by that? Sometimes you can have more than one inequalities and you'll be asked to find a range of value that satisfy both inequalities. So how do you go about solving questions like this? That's what we're going to try to address now. So as an example, what is the range of values for which this inequality here, 2x plus 5 greater than 1 and x minus 1 less than 1 are both satisfied? So the first thing you have to do is you have to solve both inequalities. So for the first one, what do I have? I have 2x plus 5 is greater than 1. And what does that give me? I have 2x is greater than 1 minus 5. So I have 2x is greater than minus 4. So I have my dividing both sides by 2. Since I'm dividing by a positive number, I don't need to reverse. So I have what? X is greater than minus 2. Secondly, now I have to solve the second inequality. And to solve that, I have what? X minus 4 is less than 1. So I have what? X is less than, when I bring this over here, 1 plus 4. I have what? X is less than 5. So the way I would suggest you do this now is to try to represent both values in the number line. Like this is the way I think about it, and it's very useful in terms of understanding. So now let's try to represent both inequalities on the number line. So first I draw my number line and I have what? My 0. So what do? I locate the point. So I have here minus 1, minus 2, minus 3, and I have say 1, 2, 3, 4, 5, 6 to infinity. So the first one, I have what? X as greater than what? Minus 2. So I come here and I have x greater than minus 2. Since it's weak, I'm just going to have a circle like this. So I have x greater than minus 2. Secondly, I have x less than 5. So I come to my 5, come over here, I will have a circle and I have what? My x value is what? Less than 5. So as you can see, the range of value that will satisfy both inequalities are the range of value that lie in between this section here and this section here, because they will meet. So it must lie in between this section here. So how do we write a number that lies in between two sections as shown when the arrow are coming towards each other? So how do we represent such? So what we do is we take the first number, which is what? Minus 2, or the smaller number. So we write what? Minus 2. Then we write less than x, and we write what? Less than 5. So again, when you have the range of values and you have drawn it and you see they are coming towards each other, you write minus 2 is less than x, which is less than 5. And this should not be strange to you, because as I explained, x greater than minus 2 is the same as saying what? Minus 2 is less than x. So this number over here, x greater than minus 2, is same as saying minus 2 is less than x. And this number over here, where you have x is less than 5, is the same thing that you have over here, where you have what? X is less than 5. So this way you have combined both inequalities to give you a range. So now we have what? Minus 2 is less than x, which is less than 5. So now these are more ways that shows how to express stuff in inequality. So now we come over here and we see that what? Minus 2 is less than x, which is less than equals to 1. So how do we represent it? As you can see, you have this circle here. You start from minus 2 and you have here, you have 1, because the inequality here is just strict. I have just less than. That is why here is not shaded. But in this second example, you have less than or equals to. That is why in this case the 1 here is shaded. The same thing applies here. You have 2 less than x less than 4. So you have 2 and you have 4. So you have 2 not being shaded because you have a weak inequality. I have x less than 4 and 4 is not being shaded. This side is not being shaded because you have a weak inequality also. So as a final example, I'm just going to write out 1 and we'll try to solve. So let's try to do something like minus 3 less than or equals to x, which is less than or equals to 7. So what do? First, we draw our number line, and once we've drawn it, we locate our 0 point and we locate the points we are trying to get to. Here, let's assume that okay, here is what? Minus 3 and here is what? 7. So what does this become? Minus 3 is less than or equals to x. So I come up, that means the value of x ranges from minus 3 to 7, and I shade here because I have a strict inequality sign. And in this 7 to here, what do? I shade it because I have a strict inequality sign also, and I join them together. So this line over here represents what? Minus 3 less than or equals to x, which is less than or equals to 7. So this pretty much sums up all you need to know as regards to linear inequalities in one variable.